In this lesson, we're going to learn how to find the area of regular polygons. Now, you're going to need two prerequisite skills for this lesson. You need to know how to find the side length of a right triangle using trigonometry, as well as how to find the interior angle of a regular polygon. I'm going to link the two videos that cover those skills in the bio section of this video. So if you need a quick review, click on those videos and please watch those two videos first. But if you're good, you understand those two skills, go ahead and continue listening to this lesson. This is a little longer than usual because each problem is about, I would say, 4 minutes long. And I want to give you an example of each type of problem you're going to encounter. So I know this video is a little longer than usual, so let's go ahead and just get into this lesson. First, let's identify the parts of a regular polygon. So I have a regular polygon here. So the apothem is the distance from the center of the polygon to any side, and it is also perpendicular to that side. So we have the apothem here in red, and it goes from the center to a side. As we can see, it creates a right angle with that side, so it is also perpendicular to the side. Okay. Next, we have the radius, which is the distance from the center to the vertex. So in black here we have the radius. So from the center to a vertex, that is the radius. And so the difference between an apothem and the radius, the apothem goes from the center to a side. The radius goes from the center to the vertex. And of course, the perimeter is the distance around a shape. Basically, we add all of the sides. And we're going to need to know that to find the area of a regular polygon. So the formula for area of a regular polygon is area equals 1/2 apothem times perimeter. So the A is for apothem and the P is for perimeter. So we're going to use this formula to find the area of regular polygons. So the first two we're going to look at, we're actually given the apothem, and we could easily find the perimeter. And of course, you know, with the perimeter, that is just the distance around the shape. And with a regular polygon, all of the sides are congruent. And so if we know the length of one side, we know the length of all of the sides. So for number one here, one side is 24.2. Therefore, all of the sides are 24.2. All right. And we have the apothem here. It is 7. It goes from the center and it is perpendicular to a side. So the first thing I'm going to do is find a perimeter. I can add 24.2 plus 24.2 plus 24.2, or since it is a three-sided figure or a triangle, I can just multiply by 3. So I'm going to do that, and that gives me 72.6. So that is my perimeter, and I'm just going to plug it into my formula. Remember, the formula is area equals 1/2 A times P. So that will be 1/2 times my apothem, which is 7, right here. And the perimeter is 72.6. When I multiply those three together, I get 254.1, and this is feet, so that would be feet squared. So the area of this triangle is 254.1 feet squared. All right, so I would like for you to try number 2. So go ahead and pause the video and try number 2 on your own. All right, so the answer is 851.2 centimeters squared. Hopefully you got that correct. This is a 8-sided figure or octagon, so you would just multiply 13.3 times 8 to get 106.4. The apothem is given, and we just plug it into our formula. So I hope you got it correct. If not, pause the video and analyze the work a little bit more. Let's take a look at this example here. So we know that we need the apothem and the perimeter to find the area of a regular polygon. But notice here we only have the apothem. And I know that this is the apothem because it goes from the center to a side and it is perpendicular to that side. So our apothem is 10 inches. So now let's locate how we could But let's discuss how we could actually find the side, because we need at least one side length to find a perimeter. So the first thing we want to do is create a right triangle by drawing the apothem and the radius. So I have the apothem here. I'm just going to draw over it in red here. That's my apothem. And then I want to draw a radius. So I'm going to go from the center to a vertex. Try to draw it as straight as possible. All right. So I've done that. And I know that that's the radius because it goes to a vertex. Next, I want to locate the interior angle where the radius intersects the vertex. So in purple here, this is the interior angle where the radius intersects the vertex. All right. Now I want to use the interior angle sum formula to find that angle and then divide by 2. And so the reason I have to divide by 2 is because when we use the formula, we're actually finding the whole angle. So we're finding the entire angle like this. However, we only want to find half of it. We want this piece, and so that's why we divide by 2. So using that formula, remember n is for sides. This is a 5-sided figure, so I'm just going to plug it in. 5 minus 2 times 180 divided by 5. Simplifying, that's 3 times 180 over 5. 3 times 180 is 540 divided by 5. That is 108. But I want to divide that 108 by 2 because I only want half of it. Okay, I don't want the whole thing. I want half of it. So I'm going to divide by 2. And I get 54. So the measure of this angle here is 54. So now, to find the side, I can use trigonometry. So that's where the trig comes in, because remember, if you have an angle and a side, you can use trig to find the other side. So now I need to find this side right here. And once I find this side, I could simply multiply it by 2, because then I would get the length of the entire side. And so if I want to find this side here, which is x, I'm given the adjacent side, right? And I want to find I'm given the opposite side, but I want to find the adjacent side. So in reference to that 54-degree angle, I have the opposite side, which is 10, and I have the adjacent side, which is x right here. So opposite and adjacent. What trig function would that be? That, of course, would be tangent, SOHCAHTOA, right? So tangent of 54 degrees, so I'm using this angle here, is equal to opposite, which is 10, over adjacent, which is x. So I'm just going to solve this problem for x to get the side, multiplying by x. Hopefully we know by now that if you're dividing, if your variable is on the bottom, you're just going to end up dividing by the trig function, but if not, this is y. So I multiply both sides by x, and then my x's cancel out. And then I kind of jumped ahead here. Let me erase that. And then I bring down x times tangent of 54 is equal to 10. Because my x is canceled out. I'm solving it like a one-step equation. Alright. Since I have x times tangent of 54, I could divide both sides by tangent of 54. So this is just, if you're familiar with finding the side length of a triangle using trig, I'm doing the same steps here, so nothing new. And then 10 divided by tangent of 54, that gives me 7.27 approximately. So now that is the length of one side, 7.27, or half of a side. So now the other piece would be 7.27, so I simply want to multiply that 7.27 by 2 to get the full side, or one full side, and I get 14.54 for one side. Okay, so if every side is 14.54, and this is a pentagon, right, the perimeter would be 14.54 times 5. So the perimeter would be 72.7. All right, so now I have my perimeter. I have the apothem already, and I just want to plug it into my formula. So area is equal to 1/2. My apothem is 10. The perimeter is 72.7. Multiplying that through, I get 363.5 inches squared. So I have found the area of this regular polygon. I would like for you to pause the video and try this problem on your own. Remember, you have to find the side first. So go through these steps here. I have them here for you. Go ahead and pause the video and try this problem on your own. Hopefully you got the problem correct. The answer is 119.52 kilometers squared. Hopefully you got it correct. If not, go ahead and pause the video and analyze the work here a little bit more. Let's take a look at this example here. So we notice that we have a side. The side is 8, so we could find a perimeter, but we need to find the apothem because that is not given. So I'm going to actually go through the same steps. So step 1, I want to create a right triangle by drawing the apothem and the radius. So apothem goes from the center to a side. All right. It's going to be perpendicular, so that's going to be a right triangle. So this is my apothem. All right. And then I'm going to draw the radius. So it's going to go from the center to the vertex. So I've done step 1. Let's check it off. Step 2, locate the interior angle where the radius intersects the vertex. So I'm going to put it in red right here. That's the angle that I want to find. So I've done step 2. Step 3, use the interior angle sum formula, then divide by 2. So this is another 5-sided figure. It's just coincidence. So again, my n is going to be 5. So plugging that in, 5 minus 2. And if you can remember from the previous problem, right, we're going to end up with 108. All right. And then we have to divide by 2. Let me erase this. This is 108, but it's going to be the same because we still have a pentagon here. So that's going to be 108, and then I'm going to divide by 2. So I'm going to get 54 for that angle. Just a coincidence that we have another pentagon here, but we're given different information. So my angle here is 54 degrees. All right, so now I need to find the apothem. And so now in reference to this 54-degree angle, I have the opposite side, which is the apothem, which is what I want to find. And I have the adjacent. So since this, I only drew half, okay, it's going because my apothem goes to the side perpendicularly, it bisects it. So if this whole side is 8, half of the triangle there would be 4, right? So I have the opposite side and I have the adjacent side. So again, that is tangent. So tangent. So I'm doing step 4 using trig to find the apothem or the side. So I have to find the apothem in this case. So that's tangent of 54 is equal to opposite, which is A. Opposite side of that 54-degree angle is A. The adjacent side is 4 because I only want half because I only drew a right triangle there. So now I just want to solve, multiplying both sides by 4. So I already have my variable by myself or by itself. So I bring down 4 times tangent of 54. You can just put that in your calculator. 4 times tangent of 54 equals. Some calculators you have to put the 54 in first. You could do 4 times 54 tangent and hit enter. But either way, you're going to get, let's see, um, 5.51 approximately. All right, so my apothem is 5.51. No need to multiply by 2 because I'm not finding a side. I already have that. I found the apothem. So my apothem is 5.51. And then my perimeter, each side is 8, right? So apothem 5.51. Perimeter is 8 times 5. That is 40. So plugging it into my formula, area equals 1/2. A is 5.51. All right. And P is 40. And I'm going to get 110.2 inches squared. Let me make this tool a little smaller. All right. So similar steps, and I can't write inches squared, but similar steps. Still using trig, it's just depending on what you're given. You might have to find the apothem, or you might have to find a side here. All right, so that is my answer here. All right, so of course, you know you have a problem to try on your own where you're given a side and you have to find the apothem. So go ahead, pause the video and try this one on your own. Hopefully you got the problem correct, 946.4 meters squared. If not, go ahead and pause the video and analyze the work a little bit more. Alright, so of course I've saved the best for last, but we're not given any of the information that we need. We need the apothem and the perimeter, but we're given the radius. I know that this is the radius because it goes from the center to a side. So we have to use trig twice to actually find the apothem and one of the sides. So I'm going to go through the same steps. First, we want to create a right triangle by drawing the apothem and the radius. I have my radius here, which is 7, right? But then I'm going to draw a line from the center to a side. So this is going to be A, my apothem. I don't have that. So I've done that. Locate the angle interior angle where the radius intersects the vertex. So here, this is the interior angle where the radius intersects the vertex, right there. Done that. Now I want to use the interior angle sum theorem because I want to find that angle and then divide by 2. So this is an octagon, so n is 8. It's an 8-sided figure, so plugging it in, 8 minus 2 times 180 divided by 8. 6 times 180 over 8. 6 times 180 is 10,000 or 1,080 divided by 8. And that is going to give me 135. Remember, I have to divide by 2 because I only want half of it. That is 67.5. So the measure of this angle, let me actually not put it there because I want to find my side. So the measure of this angle is 67.5. All right, so now I want to find the apothem first, okay? So in reference to that 67.5 degree angle, I have the opposite side, which is A. I want to find A. And I have well, this is my right angle, so that will make my radius the hypotenuse, all right? Because this is my right angle here, because that is my apothem. So remember, the hypotenuse is always opposite the right angle, so my radius is my hypotenuse. All right, so I have the opposite and I have the hypotenuse. The trig function that uses that is sine. So to set that up, sine of 67.5 equals opposite, which is A, over adjacent, which is 7. Multiplying both sides by 7, I'm just solving it. 7 times sine of 67.5 equals A. So my apothem is approximately 6.47. So that is my A. So right here, Alright, so now I have to use some trig again to find my side. So again, in reference to that 67.5 degree angle, I have my radius. I could use the apothem, but I don't want to use decimals. So I'm going to still use my radius. So if this side is x, right, in reference to this angle here, that would be the adjacent side. And again, my radius is the hypotenuse because it is opposite the right angle. So adjacent and hypotenuse, that is cosine. So setting my trig function up, cosine of 67.5 is equal to adjacent, because that's cosine. So adjacent is x over hypotenuse, which is 7. Okay, again, in reference to that 67 degree angle, adjacent is x, the hypotenuse is 7. So it has to be in that order. So just solving this, multiplying both sides by 7. So 7 times cosine of 67. So my side there is 2.68. And remember, I'm only finding half of this. 2.68. Let me make that a little neater. A lot of work here, right? So since I've only found half the side, I need to multiply that by 2, right? So 2.68 times 2, because I want to find the whole side. That's going to be 5.36. Make sure. Right? So each side is 5.36. So that's an 8-sided figure. So my perimeter is going to be P equals 5.36 times 8. So that's going to be 42.88. Sorry that my work is all over the place here. So perimeter, and I forgot to put times 5. Let me just make this a little neater here. Sorry about that. That is 5.36 times 5. So my perimeter is 42.88. Kind of sloppy here. So this is my perimeter, okay, and my apothem is 6.47. So finally, I have the information I need. Area equals 1/2 apothem 6.47 times perimeter, which is 42.88. Just plug that in my calculator, and I get 138.72 millimeters square. All right. So now I have found the area of this regular polygon, and of course, I'm going to want you to try the last one on your own. All right, we finally made it to our last problem, so please pause the video and try this problem on your own. Remember, you have to find the apothem and the side to find a perimeter before you can plug in your information. So go ahead and pause the video and try this problem on your own. All right, I hope you got it correct. The answer is 858.41. If not, please pause the video, analyze this work here to make sure that you understand how to find the area of a regular polygon. All right, so we finally reached the end of our lesson. A lot of information we had to cover there. But I want to thank you for learning with me. Some related videos are on the polygon angle sum theorem and finding the side length of right triangles using trig. If you haven't already, please like, comment, share, and subscribe. And again, I want to thank you for learning with me.